All right, hello everyone. My name is Jacob Schuster. I'm the main team lead for the Material Atlas project for Capstone 2. And today I'm going to be demoing what we were able to accomplish over the semester. Material Atlas, if you don't know, what we essentially made is a database to facilitate cross-collaboration between material scientists, so the people actually developing materials, and specifically sustainable materials, and the people who are going to be using that material in practice, so the architects and the engineers and the project managers. Okay, so this is our landing page. We have a nav bar at the top, a little bit of information about the website and what features we have. We also have the ability to log in and create an account. So if we go to register, you can see we collect information like first name, last name, username, password, email, institution, and research area, and then title role. And something I should note, we don't take personal emails, and we do actually check that the person is associated with either a university or a reputable company. And then if you want to log in, you hit the button here, and you can input your information. All right. So right now, I wanna show you the actual page you see when you upload a material. If you're logged in, you'll get a page that looks like this. You have some instructions at the top. Upload a research paper to get started. Our AI will extract the information from the paper and pre-fill the form for you. Once completed, click the submit button to add the material to the database. You can choose to either fill in the information manually, and this form is completely working. Everything's dynamic. You can add elements, you can add mixes. We just collect some standard metadata and then details about the material you're uploading. But we also spent a lot of time integrating AI into the app, because one problem a lot of other material websites have is that it takes a lot of effort to upload information. So it's really hard to get researchers to do it. And if you don't have data, you don't really have a product. So really the angle we wanted to use AI to offload as much of the manual information processing as we could away from the user. So that's what I'm going to be showing off today. You can upload, here I have a research paper, hit open, and it'll take a minute. While it does, I'm going to talk a little bit about what it's actually doing. So over here we have a Python API route. This is fast API, by the way, where we're taking in the routes extract paper, we're taking in a research paper, and we're calling a bunch of natural language processing libraries on it. So the first thing we're doing, we're calling unstructured, which is a library to parse out data from PDF documents. We're pulling out the images and the tables, and we're splitting them up over here. Next, what we do, we create a vector database out of the images, but in order to map the images to the database, we first generate a text summary of them and embed it. So that's what these next few functions are doing. This is assembling that vector retriever I was talking about. And then what we do now, these are just helper functions to like resize the image and convert it. What we do next, we give it, we're using GPT-4, we give it a prompt. You're a material scientist tasked with extracting information from research papers. We give it the relevant images and tables from the paper as context. And then we query the chain and we return the result back to the user. And you can see it's done processing. It was able to fill out most, if not all, of the fields. So after you've looked over it and everything looks good, you can hit submit and it'll add it to the database. All right, cool. Now I'm going to show off the database page of the app, which is where you actually you can view all the records we have in the database. So at the top we have a search bar where you can search by keywords. You can choose to view either a graph visualization, what I have here, or a table, which we'll show in a minute. For the graph, we're actually clustering the materials based on the semantic content of their overview. An overview is a field we collect in the material upload form. So you can see we have a few clusters here. Some materials are related to ecological engineering, some are related to biocement, and others are living materials. So it's just a really quick and easy way to filter out the general type of material you want to look at. And what you can do now, if you click on a material, it'll bring up another visualization at the bottom. And what you have here is the representation based on what we have in our graph. So you can see the material has multiple mixes, each mix has multiple elements, and you can actually chain these graph queries together by clicking on either a mix. We can see all the elements related with it, all the materials related with it. I could click on another material, I could click on another element to see which mixes it has. So it's really powerful how you can chain queries like that, and the amount of insights you can gain can be incredible. If you don't want to look at the graph, we also have a table view, which will have the detail just as like plain text. And yeah, that's really it for now. I'm really excited of what we were able to build over the semester, and I can't wait to keep working on it and building out some of the other features I was talking about.